All right, it's Wednesday evening. That means we are back for Cheg's Algebra and Pre-Calculus Office Hour. We're going to get started here in just a minute. We're going to give some people a chance to come join us here. But we are excited to be going over your algebra and pre-calculus questions and also helping you be successful as we're kind of getting close to exam season here right around the corner. So I am very excited to do that. So a big hello to everyone who is rolling in right now. Welcome to our live office hours that are brought to you by Chegg. I'm at Wallace. You probably recognize me from my channel at Wallace, where I do memes, usually about calculus, but sometimes algebra as well. I say come for the memes, come for the trends, but stay for the math. For those of you that have joined one of our live events before, I want to welcome you back. For those of you that are new here for the first time, the goal here today is to help you understand your algebra and pre-calculus concepts just a little bit better. I'm here every week at this time. It's 5 o'clock Pacific time, 8 o'clock Eastern time to do just that. You can think about the office hour. I'm here to help. So if you have any questions as you're logging in, don't be shy. Stick them in the chat, and I'll do my best to answer as many of them as I can during our hour together. I've got a few icebreaker questions to get us started, but please start using that chat. Start telling us what questions you want to take a look at. I had some questions I didn't get a chance to get to last time that had to do with logarithms. So I thought we would start with logarithms today. We're going to solve the equation log base 2 of x plus 2 log base x of 8 equals 5. All right. So the challenge with this problem is that the bases of the two logs are different bases. When they have different bases, we're limited in how we can combine them together. We're going to try and force them the same base. And I don't really want to work with a base that's a variable. So let's change the log base x of 8 into a log base 2. And the way we can change a base, you remember the change of base formula is log base a of b. I can change this by taking the log of the number, the input, and divide by the log of the base. And that's what we're going to do then. Our new base is going to be 2. So my equation is still log base 2 of x plus 2 log base 2 of the 8. And divide by log base 2 of the old base, which is an x. And that's still going to be equal to. Now that we've got all of these log base 2's, now we can start trying to solve. In fact, let's take a quick moment to look at what log base 2 of 8. Remember, a logarithm is just asking that question, the base to what power gives me that number? So the base 2 to some power equals 8. 2 raised to what power is 8? 2 to the third is 8. So this log base 2 of 8 can simplify. So now I've got log base 2 of x plus 2 times 3, which is 6, over log base 2 of x equals 5. And then the next annoying thing that I want to take care of is the fact that I've got this fraction here. These fractions make the solving a lot more difficult. So what are we going to do? We can multiply everything by this denominator. We can multiply by a log base 2 of x all the way across. And when I do, it's going to reduce out in the middle, leaving me with log times log. Well, that is log base 2 of x squared plus a 6 equals 5 times log base 2 of x. Now, you might recognize that this equation is quadratic in form. It is something squared with a something. If we make it equal to 0, we should be able to factor this expression and solve. So let's subtract off this 5 log on both sides. So we get log base 2 of x squared, subtracting off the 5 of log base 2 of x, and adding 6 to make it equal to 0. because if it equals 0, we can factor it and set each factor to 0. I'm running out of space here, so I'm going to come over here. We're going to factor this to something equal to 0. Well, what times what gives me log squared? Log times log gives me log squared. So we've got log base 2 of x and log base 2 of x. Then I want two things that are going to multiply to 6, but add to a negative 5. 6 is 2 times 3, and if they're both negative, we end up with our factored form. The nice part about being in factored form is I can set each factor individually to 0. So if this one equals 0, I can add 2, and we know that log base 2 of x is equal to 2. I set this one equal to 0, and we can add 3 to both sides, so I know that log base 2 of x is equal to 3. Which means if I want to solve it, I just have to convert from log form into exponent form. The base is 2, the exponent is 2. 2 squared equals x, or x equals 4, is one solution. The base is 2, the exponent is 3. So 2 to the third equals x, or 8 equals x. And so our two solutions for x are 4 and 8, and we've solved this problem with logarithms. For those of you that are just joining us, welcome so much to our Chegg office hour. We're talking about algebra and pre-calculus. I see a question on the chat for the SAT on Saturday. I want to wish you the best of luck on that SAT. At this point, I would say the best strategy to do is just prepare yourself for that exam physically. Get a good night's sleep beforehand. Get a good breakfast the morning of. Plan to arrive early with extra pencils, and you are going to do just great. Another question came in about what is a log. That is such a great question because logs are such a powerful tool, but they only become a powerful tool if we really understand what we're doing and what they are. So I'm going to erase this, and then we're going to go back and answer that very question. What is a log? And as I erase, though, this is Chegg's live office hour for pre-calculus and algebra. So if you have any questions on pre-calculus or algebra concepts from your class, whether it's topics like logarithms or a specific problem that you want us to solve, stick it in the chat and we'll do our best to answer those questions as they come in. All right, question was, what is a log? Here's the thing. Often we'll have problems that are of the form a to the b equals, well, I don't like those letters. Let me change. Let me restart. All right, we're going to take some base, and we're going to raise it to some exponent, and we're going to say that's equal to some answer. So B for base, A for answer. So for example, I might have 3 to the 4th power equals 81. I've got a base, an exponent, and an answer. This is probably the most common way that you've seen these exponents written, but sometimes exponential problems are a little difficult to get to our solution. And so what we want to do is we're going to rewrite them into a log form. So this is going to be an expression that's exactly the same. It's just written differently and solved for a different part. With a log, it's going to have a base. So we put the base as a little subscript. It's the same base as the problem. And then the answer is what goes into the log. And the exponent comes after the equal sign. So these two expressions are really saying the exact same thing. A base to an exponent equals an answer. A base to an exponent equals an answer. So for with the numbers in there, we would say log base 3, because that's the base, of 81, that's the answer, is equal to the exponent. You'll often hear people say a log is an exponent because it literally equals the thing that's the exponent. And so if I wanted to figure out what log base 4 of 16 is, what that's saying is we've got a base of 4 to some exponent is equal to 16. Well, 4 to what exponent is 16? 4 to the second exponent equals 16. And that's how we can evaluate logarithms. All right, We've got Logan on TikTok, wants to know about finding the zeros of a polynomial using synthetic division. Let's do that. That's a great problem. So I'm going to erase this here, and we're going to go over to synthetic division and finding zeros of a polynomial using this thing called the rational root theorem. Let's do, actually, I don't like that problem. I'm going to make up a new problem, shall we? Just going to pull one right off of the book here. Hopefully, I don't pick one that gets too ugly. Let's try 6x to the 4th plus 7x cubed minus 36x squared minus 7x plus 6. And we're going to try and find the roots of this polynomial with synthetic division. Excellent. All right, so what we're going to do is we're going to try and guess what the factors might be to this polynomial and see if those factors reduce out. Now, here's a tip, though. We're not just going to make random guesses. We're going to pick specific intentional guesses. The first set of guesses are going to be factors of this last number. So I'm going to try either positive or negative 1, because they divide into 6. Positive negative 2, that divides into 6. Positive and negative 3, that divides into 6. And positive and negative 6. Probably, that limits us down to 8 options, really. Probably one or more of those 8 options is going to work on this polynomial. But we have to test it to figure out which one's going to be our solution. So here's what we're going to do. We're going to make a little box in the corner, and we're going to put our first guess in there of 1. Then across from the box, we're going to put the coefficients of this expression. So we've got a 6, 7, negative 36, negative 7, and 6. Now, one thing to be careful of here, it doesn't come up in this problem, but something to watch out for, and instructors like to put this on the test, so it's good to be aware of this for the test, is one of these might be missing, and so it goes from cubed down to first power, and there's no squared. If there's no squared, you have to put a 0 in here to represent the 0 squared. So you have to count down. If this is 4th, these have to be 3rd, 2nd, squared. What's that? 4, 3, 2, 1, 0 for the exponents. There we go. I got off of my counting somehow, but that's okay. Now we're going to leave a space, leave a row, and put an equal sign. And the goal is to end up with a 0 in the very bottom box. How that's going to work is we bring that 6 straight down, and it's going to get multiplied by the number in this top left box. 6 times 1 is 6. And then we're going to add the 2 numbers that we end up with. 7 plus 6 is 13. And then we kind of repeat the process. 13 times 1 is 13. Negative 36 and 13 is negative 23, sorry, whoops. Negative 23. Times 1 is negative 23. Plus 7 is negative 30, plus negative 7. Times 1 is negative 30, and you can see this is not going to give me 0 at the end. So we regroup. Positive 1 doesn't work, so let's take positive 1 off of our list. Negative 1 is another option, so let's try negative 1. Bring down the 6. 6 times negative 1 is negative 6. Negative 6 and 7 is 1. 1 times negative 1 is negative 1. Negative 36 and 1 is negative 37. Negative 37 and negative 1 is 37. Plus negative 7 is 30. Times negative 1 is negative 30. And in the bottom corner again, did not get 0. That's okay. Regroup. Negative 1 doesn't work either. Let's try 2. That's the problem when I grab a problem randomly. We don't know what we're going to end up with here. Trying 2. Hopefully get 0 in the bottom corner. Bring the 6 down. 6 times 2 is 12. 12 and 7 is 19. 19 and 2 is 38. 38 minus 36 is 2. 2 times 2 is 4. 4 minus 7 is 3. Negative. Negative 3 times 2 is negative 6. Negative 6 and 6 is 0. We found it. We have found one of our zeros. One of our solutions is that x equals this number up in the corner. So technically what I need to do, though, to make it a factor, factors like to be equal to 0. So if I subtract 2 from both sides, x minus 2 equals 0 is one of the factors of this expression. But it's only one. We need to find 4 factors. Now, usually we're going to keep going until there's 3 numbers left, because when there's 3 numbers left, we can usually do the rest just using our normal factoring skills. But we don't have 3 left, so we're going to continue on. Now with this new row, we're going to try and factor out, well, we tried 2. Let's see if 2 works again. It worked once. Maybe we'll get lucky and it'll work a second time. Bring down the 6. 6 times 2 is 12. 19 and 12 is 31. You can already see this is going to get really big and it's not going to work. 31 times 2 is 62. Adding 2 is 64 times 2 is 128. That's not going to give me 0. All right, so positive 2 is out. Next, let's try negative 2. Do it again. Bring the 6 down. 6 times negative 2 is negative 12. Negative 12 plus 19 is 7. 7 times negative 2 is negative 14. 2 and negative 14 is negative 12. This isn't going to work either. 24. It's not going to give me 0. So 2 is out. Hopefully one of these works, because otherwise we have to deal with fractions, and I was hoping not to deal with fractions. That's what I get for just picking a number at random. Let's try the number 3. Bring down the 6. 6 times 3 is 18. This is 37. Boy, this is getting really huge. 37 times 3 is 90 and change. That's way too big. You can already tell we're not going to be able to make that work. Let's try negative 3. Bring down the 6. 6 times negative 3 is negative 18. 19 minus 18 is 1. 1 times negative 3 is negative 3. Negative 3 and 2 is negative 1. Negative 1 times negative 3 is a positive 3. And there it is. We got 0 finally. Whew. This problem's taking longer than I thought it would. But we have successfully reviewed a lot of synthetic division. And we found another solution. X equals negative 3. Which means we can add 3 to both sides to make it into a factor that's equal to 0. X plus 3 equals 0. That's going to be our second factor. Now, we could continue doing this if we wanted to, but we don't have to, because when there's 1, 2, 3 pieces left, that's going to stand for 6x squared plus 1x minus 1. And 6x squared plus 1x minus 1, we should be able to factor just kind of using a quick guess and check method. 6x squared is probably going to be 2x times 3x. 1 is probably 1 times 1. And if I make the positive 3x in the middle and the negative 2x on the outside, that'll give me the 1x in the very center. So we've got our 1, 2, 3, 4 factors. This original expression is equal to x minus 2 times x plus 3 times 2x plus 1 times 3x minus 1. And we have factored the entire problem. Excellent. Thank you, Leah Adams, celebrating with us. I really appreciate it. Lots of great questions coming in the chat. Remember, this is your live office hour with Che. Correct. This is synthetic division and the rational root theorem that we went through to factor this expression. And we are here to answer your questions every week at this time. So at 5 o'clock Pacific time, 8 o'clock Eastern time, mark your calendars and come with your algebra and pre-calculus questions. We are going to do our best to answer as many of them as we can. We've got some tips to help students become interested in math. Well, to become interested in math, there has to be something fascinating about the math that we're talking about. It would be really boring to be like, Well, we're going to learn how to add up a bunch of numbers. And if it's an arithmetic sequence, the arithmetic sequence has a formula of n time, or what is it? N times the first term plus the last term divided by 2. That is really boring. Yes, your question is calculus office hours tomorrow. Yes, 4:15 Pacific tomorrow, 7:15 Eastern tomorrow. We're going to be doing calculus office hours, and I think we're going to be doing them exclusively on TikTok. So make sure you're following Chegg on TikTok, because the calculus office hours tomorrow are going to be exclusively on TikTok. All right. But as I was saying, if you've got a whole bunch of numbers you want to add together and you want to make it interesting, tell a story. Tell why it's significant. Tell a story about little Goss, right? Goss was in his school and he was misbehaving. He was a bad little student. Goss was asked by his teacher, forced by his teacher, punished by his teacher to add up all the numbers from 1 to 100. And he was put in a corner and told until he could add 1 plus 2 plus 3 plus 4 plus 5, all the way up to 100, he had to stay in the corner. Well, Goss looked at it for about 15 seconds and said, oh, well, the answer is 5,050. Blew the teacher away, who was convinced that he cheated or he was lying, found out he actually got the correct answer. How? Here's what Goss did. We take the numbers from 1 to 100. If we write them backwards, it's going to be 100 plus 99 plus 98 plus, all the way down to 2 plus 1. If I were to add up all of these numbers, we get 101. 99 plus 2 is 101. 98 plus 3 is 101. Plus, 101 plus 101. What I have ended up with is 101 occurring 100 times. The problem with this is we have added all the numbers twice, right? 100 is here and 100 is here. 1 is here and 1 is there. We've added every number twice. So what we're going to do is we're going to divide by 2 so that we undo the adding of every number twice. Well, I can reduce 100 over 2. That's 55 times 101, which is going to equal 5,050. That's how Goss did it. Very smart, very tricky, but ultimately it leads us to this formula that the 101 came from taking the very first term, we'll call it a sub 1, and adding the very last term, we'll call it a sub n. That gave us n. We had 100 numbers. It gave us n, the number of numbers, times. Then we divide by 2 to offset it, and this becomes the formula for the sum of the n terms on an arithmetic sequence. And now we can use that formula to answer any question, any sum of an arithmetic sequence. So by finding the fascinating stories, by finding the use, by finding what makes math exciting, it's going to be catchy. But if you just focus on the formulas, it's just memorizing a bunch of dry stuff. You can't do that. You need to be excited about it. And that is what we're doing. Wow, my purple is not erasing. Hold on one second. Get my spray bottle here. And I'm back. Maybe this will erase the purple a little better. There we go. All right, so this is Chegg's live office hour, talking about algebra concepts. What are you doing in your algebra classes? What questions do you have? I see that Justin, the baseball kid, wants to talk about factoring trinomials of the form x squared plus bx plus c. I'm going to take it one step further and put an a in front of the x squared, because if you can learn how to factor with a in there, if a is equal to 1, it just becomes an easier version of that same problem. So let's say I wanted to factor 5x squared minus 19x plus 12. 60, 14, and 12. I hope that works. It should work. We're going to find out if it works. If it doesn't work, I've got a backup. All right. Lots of ways to factor. Some people factor using the box method. Some people factor using the AC method. Some people factor with the guess and check method. It doesn't matter which factoring method you use as long as you know how to factor, because you need to be able to factor to move on in mathematics, because we can do so much more with factors than we can do with terms. If things are multiplied, we can reduce radicals, we can reduce fractions, we can simplify expressions. If they're added, we're kind of stuck with it. So we need to make it more usable by factoring. It never goes away. This is not one of those skills you learn for the test and forget. You need to know how to factor. You're going to factor for the rest of your mathematical career. I like the method called slide and divide. We're going to slide the 5 over to the 12. When we do, we're going to get x squared minus 19x plus 5 times 12 is 60. Then what we're going to do, this does factor, by the way, is we're going to factor this easier expression first. Now, this is nice because if you already have where the x squared has a 1 in front of it, you're already on this step. Half the work is done. We're going to look at factors of 60. 60 is 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10, 7, 8, 9 don't go in there. So that's it. These are all the factors of 60. We are looking for the factors of 60 that add to this number in the middle. And if you notice, 4 and 15 can add to negative 19 if they both are negative. So we're going to use these numbers and say it's going to factor to an x minus 4 and an x minus 15. And that is how we factor the easier orange expression. Now, wait a minute, Wallace. You said we wanted to factor this blue expression on top where 5 was in front. Correct. But this is going to help us factor that blue one, because I said this method is called slide and divide. We slid the 5 over. Now we need to make sure that we can divide out the 5. So the 5 was hiding in here. Now it's going to come out. We're going to divide each term by 5. If it reduces out, we're not going to worry about it. So 15 over 5, that reduces out to 3. There's no fraction left. So this new factor is now x minus 3. If it doesn't reduce out, I've got 4 over 5 here. If it doesn't reduce out, that 5 is going to go in front and be 5x minus 4. And then this is going to be the factored form of the original, more challenging problem. Any questions on factoring? Do you want to see more factoring? Do you want to see another example of slide and divide? Do you want to see another method? Do you want to see the AC method, the box method? Let me know in the chat if you want to see more factoring, or if you want to move on to another topic from your pre-calculus or pre-algebra class. This is your office hour with Che. Do you want to talk about functions? Do you want to talk about rational expressions, reducing rational expressions, multiplying, adding rational expressions? Do you want to talk about logarithms and exponents? Do you want to talk about trigonometry? Maybe you want to do some trig proofs. What are you taking a look at right now in your class? Put it in the chat and we will take a look at it. Hey, the question came in about completing the square. Such an important skill, and it's directly related to this, because if we cannot factor, a lot of the times the other thing that we do is we will completing the squared. And it looks like we got some questions for more factoring. We'll come back to that. Let's actually do a problem we can do by complete by factoring or completing the square. Let's do 6x squared plus 7x minus 3. And we're going to factor it first. Let's make it equal to 0. We're going to solve it by factoring, and we're going to solve it by completing the square. If we're going to solve it by completing the square, the first thing we need to do is isolate the stuff with x from the stuff without x. So what we're going to do is we're going to add that 3 to the other side, giving us 6x squared plus 7x equals 3. Step number 1, separate the x's from things without x. Step number 2, we need to get rid of anything in front of x squared. We get rid of that 6 by dividing by 6. But if we do that, we have to divide by 6 all the way across, which is going to give us x squared plus 7/6 of x is equal to 1/2. 3/6 reducing to 1/2. So step 1, separate x from the numbers. Step 2, remove the number in front of x squared. Step 3, we're going to take half of this middle number, so 7/6 times 1/2, and we're going to square that answer. That's going to give us 7/12 squared, which is 49 over 144. This is the magic number that we need to make this left side a perfect square. We're going to add 49 over 144. But if you do it to one side, you have to do the same thing to the other side. Drop my red, 1 second. And we're back. I always feel like this disappearing act, like I should have some stairs here off my camera screen. I don't know. Maybe it's just me. All right, we're going to factor then this left side. This left side we purposely designed so that we could take the square root of the first term, the sign from the middle, and the square root of the last term. So we get x plus 7/12 squared is equal to fractions. In order to add fractions, we need to have a common denominator. I wrote 149 here. This should be 144. We said 144 here. Not sure what happened there. The common denominator is 144. So 2 times what is 144? 2 times 72 is 144. To give me that denominator of 144. And we're taking 72 plus 49 is 121, I believe. Right? 70, 80, 90, 100, 10. 9, 10, 11, carry the 1, 8, 12, 12. Yeah, yes, okay. I don't have a calculator. Check my math, though, if you have a calculator handy. What's nice about the equation we end up with is now it's really quick to get to the x. What I'm going to do is we're going to get rid of the square by taking the square root of both sides. And I'm going to come over here because we're running out of a little space. But we end up with x plus 7/12 is equal to, remember, when we take the square root of both sides, we end up with a plus or minus. So it's plus or minus. The square root of 121 is 11. The square root of 144 is 12. And then we get x alone by subtracting 7/12 from both sides. 7/12, I said. So x is equal to -7 plus or minus 11 over 12. And if we want to be really clear about who our two answers are, we can add and subtract. -7 plus 11 is 4/12. -7 minus 11 is -18/12. Let's go ahead and reduce them. And x is equal to 1/3. And dividing by 6, -3/2. That is completing the square. It is a lot of steps. But what's nice is they are the same steps all along the way. So if I gave you another problem, it can't be a hard problem. It's going to be the exact same problem because you're going to go through the same steps. You're going to separate the x's from the variables. You're going to get rid of what's in front of x squared. You're going to add half of this middle term squared. That'll make it a perfect square. You can get rid of the square root. Don't forget the plus or minus and isolate the x. Every problem is exactly the same. The key to get good at this is to practice. All right. I said we were going to do it 2 ways because there was also a request in the chat to review some more factoring and practice more factoring. So we're going to go back to the original problem. We're going to solve it by factoring. This one, because it does factor, it's probably going to be easier to solve by factoring. So let's see. I'm going to save this answer here, see if we get the same answer. I'll erase everything else, though. And we're going to factor it using that same slide and divide trick that I showed you earlier. The idea of slide and divide is I'm going to slide the 6 into the 3, which gives me x squared plus 7x minus 18. And we won't set it equal to 0 yet because we're going to first factor this easier expression because 18, its factors are 1 times 18, 2 times 9, 3 times 6, and 4, 5, and 6 don't go into it. Well, 6 does. We've already got it on our list. We want the pair that we can use to get 7x in the middle. Well, that's this middle one. Because if we've got a -2 and a +9, that's going to give me 7x. So the factors I'm going to use for this easier problem is x minus 2 and x plus 9. But we're not going to forget this method is called slide and divide. We did the slide of the 6. Now we have to divide the 6 out. So we're going to divide both numbers by 6. And if there's anything left over in the denominator, it's going to go to the front. Well, 2 over 6 can reduce to 1/3. The 3 goes up front, and I have 3x minus 1. 9 over 6 can reduce to 3/2. The 2 in the denominator goes up front, and we have 2x plus 3. And now we've factored the original problem. The whole reason that we factor is so that we can set each factor equal to 0. We have 3x minus 1 equals 0, and 2x plus 3 equals 0. Add 1 and divide by 3, and x is 1/3. Subtract 3 and divide by 2, x is -3/2. And sure enough, those are the same 2 numbers we got when we solved by completing the square. What are the potential uses of factoring? So many. So there's a lot of applications in calculus, physics, engineering, chemistry, what's the other science? Biology. I was losing it there for a minute. Lots of those applications are going to require us to first factor before we can do the other applied steps in those classes. So it's really important that we get this foundational skill of factoring so that when we get to those more advanced classes, we're ready to do that factoring. So many great questions are coming in, and I said I was going to try to answer as many as I can. I'm going to scroll back, see what I've missed. Integration, a lot of good integration questions. We're going to do calculus tomorrow at 4:15 Pacific time, 7:15 Eastern time. It's going to be exclusively on TikTok, so you have to be following Chegg on TikTok to get that live. It's going to be great. Best study method. Hector, that's a great question. How do you study for your math classes in order to be successful? You're not going to like my answer because it's really simple. You need to practice. I have watched Venus Williams play tennis for years. She is the GOAT, the greatest of all time. Men or women, I would definitely say Venus Williams has it hands down. She has won so many tennis tournaments. She's amazing. But watching her play tennis is only going to make me marginally better. What I need to do to get better at tennis, I need to play tennis. Watching Michael Phelps swim, I'm only going to get marginally better at swimming. Watching the American gymnastics team, Simone Biles, I'm only going to get marginally better at gymnastics. I need to actually do the sport to get better at it. Math is the exact same way. If you want to get better at math, you have to do math. And don't just do problems you're good at because you're already good at them. Do the problems that are a challenge, stew in the discomfort, and then ask questions. Seek to learn, not just get the answer. And you can find some amazing success in your classes by forming a study group, teaching each other concepts, practice, 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 ask questions, and be curious about why things work. And you can find success in mathematics. Excellent. All right. We want to do graphs of tangent and cotangent. Just the regular graph of tangent and cotangent. And then after that, we can look at some trig identities. Okay. So I think the best way is just kind of think about what tangent and cotangent are really doing. So I've got my unit circle here. Pictures are always better with sound effects. All right. We start here at 0, 0. Up here, we're at 1 or 0, 1. Whoops, we're not at 0, 0. We're at 1, 0. Wallace. There we go. Back here, we're at negative 1, 0. Down here, we're at 0, negative 1. Maybe it'll help to look at the quarters. Let's not do the entire unit circle. But at the quarters, we've got root 2 over 2, comma root 2 over 2. What's important with that is they are both the same, because we're going to do tangent, and tangent is going to divide them. And anytime we divide something by itself, the answer is 1. That's why that's nice. Over here, we've got negative root 2 over 2, comma root 2 over 2. Down here, they're both negative root 2 over 2, negative root 2 over 2. And over here, we've got a positive root 2 over 2, and then we're down negative root 2 over 2. If I'm looking, drop my pen again. 1 second. And back. I feel like it's this game of peekaboo, right? Ooh, gone, back. Okay. I noticed my bald head stayed in the screen there. Hopefully you don't get blinded by the reflection. All right, we're back. If we're taking the tangent of some angle, we can pick various angles and test them. So at the angle of 0, tangent of that angle is y divided by x, right? Tangent is cosine over cosine, or y divided by x. 0 divided by 1 is 0. When the tangent is at pi over 4, that's here, we've got something divided by itself. The answer is 1. Over here, it's undefined because I can't divide by 0. So at pi over 2, it does not exist. We're going to actually end up with an asymptote. So let's go backwards maybe. Let's do some more thetas. Let's go backwards pi over 4. If I go backwards pi over 4, I've got a number divided by itself, but one of them is negative, so we get negative 1. And then down here at backwards pi over 2, it's also going to be undefined, because when I do the y divided by the x, we can't divide by 0. So if we were to try and graph this relationship, we'll have our pi over 4 here. Actually, let's make that pi over 2. We'll do pi over 4, pi over 2, negative pi over 4, negative pi over 2. At pi over 2 and negative pi over 2, the graph is undefined. The reason for that is because we're dividing by 0, it's going to create these vertical asymptotes. Then we've got a point at 0, 0. At pi over 4, it's 1. At negative pi over 4, it's negative 1. And that's where we kind of get this. That is a terrible connecting of the dots. Wow. Let's try again. Is that a little better? That's how we get the graph of tangent. Excellent. All right. So we wanted to take a look at not just graphs of tangent, but also maybe some trig identity verification. So let's take a step away from graphing and go over to proving some trig identities. This is your office hour brought to you by Chegg, hosted by Chegg with @WallaceStem. Remember, we're answering your questions about pre-calculus, about algebra. Stick them in the chat. Don't be shy, and we'll do our best to answer as many of them as we can. We are here every week at this time at 5 o'clock Pacific time, 6 o'clock Eastern time. And if you want the full schedule, scan the QR code in the corner, and you'll get our full schedule, including our calculus study hour, which is tomorrow at 4:15 Pacific time, 7:15 Eastern. All right. We want to do some proofs. Let's say that the cosecant squared of theta minus 1 over the cosecant squared of theta minus the cosecant of theta, that is equal to 1 plus the sine of theta. And we are going to prove that identity is true. With proofs, our goal is to only work on one side of the equation, do some manipulation, and end up with the other side. How do we do that? Well, if you don't know what to do on a problem, a good general strategy is to change everything into sines and cosines. So let's do it. Cosecant is the reciprocal of sine. So we've got 1 over sine squared of theta minus 1 all over 1 over sine squared of theta minus 1 over the sine of theta. When you make that change, almost always you're going to end up with little fractions inside of the bigger fraction. We want to get rid of those little fractions. And the way we get rid of those little fractions is we're going to multiply top and bottom, left and right, by the common denominator, which is sine squared of theta. It's the same thing on top and bottom. That's what makes it legal. It's going to distribute through. So sine squared over sine squared reduces out, and I'm left with 1 minus sine squared of theta. Over. Sine squared and sine squared reduce out, so I'm just left with 1 minus sine squared over sine. One of them reduces out, 1 minus sine. Now, part of me sees this 1 minus sine squared and gets excited because we know 1 minus sine squared is cosine squared. That's really nice. But that's not what we want to do here, because we actually want to end up with sines in our answer. So resist the temptation to go down that route. 99% of the time, if you've got 1 minus sine squared, you're going to change to cosine squared. This is that 1% of the time, though. Another strategy we can do to help us reduce fractions is we can factor. So let's see what we can do if we factor that numerator. Notice that numerator is a difference of squares. That's the other thing we do a lot with the Pythagorean identity. It's a difference of squares. 1 is 1 times 1. Sine is sine times sine. Sine squared is sine times sine. If one's positive and one's negative, we have now factored that numerator. By the way, I should have said, and here is one reason why you asked earlier, why do we spend so much time factoring? What do we use it for? Here's an example of where we need to do the factoring. We cannot do any reducing on this fraction. We can't cross off a sign and cross off a sign because of those minuses. When things are added and subtracted, there's very little reducing and simplifying that we can actually do. But when things are factored, now we can simplify. So we've got this 1 minus sine on top and bottom. Reduce them out, and we're just left with 1 plus sine, which is what we wanted on the other side of the equation. So QED, we are done. All right. Yes, exactly right. You saw that difference of square. Unique user 178 on TikTok. Great work. Question came up from Hector. Wants to know, what foundational skills should we focus on before starting pre-calculus? Well, probably the best thing you can do is just start to get really comfortable with integers, positive and negative numbers, and fractions. All the rules for adding, subtracting, multiplying, and dividing with positives and negatives and fractions, And then also just being able to solve an equation. That's probably really, really important to it. All right. Where to shade the graph with greater than or equal to inequalities. Let's do it. Let's see. You're talking about problems. I think you're talking about like quadratics, like x squared minus x minus, let's do minus 12. No, let's do minus 2x minus 15 is less than or equal to 0, right? There's going to be some range. We don't know which range is going to be shaded on the graph to show this is our solution. Well, first step I'm going to do is, you guessed it, we're going to factor it. Because this has already got a 1 in front, we don't have to do any sliding and dividing. It's already set up. So it's going to factor to something that multiplies to 15 and adds to 2. That's going to be plus 5 and minus 3. No, it's not. That's positive 2. Let's do minus 5 and plus 3. There, that's minus 2. And we're going to say that's less than or equal to 0. Well, if we set each of these factors equal to 0, we find out that x is equal to 5 or negative 3. That's going to help us actually make our graph for the function. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. All right. So we said the solutions are 5 and negative 3. Technically, we could use this negative 15 to tell us there's a y-intercept at negative 15. So it's going to come way down and back up. So the question is, do we shade above or do we shade below? And this trick I'm going to teach you works for any function. So if you were just doing a regular line and you were trying to decide to shade above or below, if you're doing a cubic or a sine or something more exciting, this trick can help you decide whether or not to shade up or down. I'm going to look at the point 0, 0, which is right here, right? 0, 0. I'm going to plug 0, 0 into this function to see if we get a true statement. So if x is 0, we get 0 squared minus 2 times 0 minus 15 is less than or equal to 0. Well, 0 squared, that's 0. 2 times 0 is 0. 0 minus 15 is negative 15 is less than or equal to 0. Is this a true statement? In this case, yes, it is. This is a true statement. Being down 15 is worse than being at 0, right? Negative 15 is less than 0. If I get a true statement, I'm going to shade the section that's got my 0, 0 point on it. So I'm going to shade all of this. Everything inside the parabola. If this was false, let's say I got 7 is less than 0. And we're like, no, 7's not less than 0. If I get false, I'm going to shade the other part. So I don't shade 0, 0. I would shade everything around it in that case. That's how I decide what to shade, is I plug in 0, 0, and then I go off of that. So here I want to be between 5 and 3. So in interval notation, it's just going to be from 5 to 3. If this was flipped the other way, it would be outside of 5 and 3. That is how I do my graphs. Excellent. This is Cheg's live office hour, hosted by Cheg, to answer your questions about pre-calculus and algebra. We're here every week at this time at 5 o'clock Pacific time, 8 o'clock Eastern time. So make sure you mark your calendars, scan the QR code in the corner so you're here for future sessions. We have time to answer probably about one more question. Let's see, logarithmic functions tips. Tips with logarithmic functions. What are you doing with logarithmic functions? Are you working with log properties? For example, what if I have log base 3 of 9 x squared over, let's do z squared times y. We can expand this out into several logs. And this seems like a very trivial exercise to expand it out. But when you get to calculus, expanding logs is going to make a lot of problems a lot easier to solve and work with. Remember what I told you earlier about logarithms, for those of you that were here. A log is an exponent. If a log is an exponent, we can treat these like exponents. Positive exponents go to the top. Negative exponents go to the bottom, which means all of these tops are going to be positive logs, and the bottom is going to be negative logs. So I've got a positive log base 3 of 9 and a positive log base 3 of x squared, because those are on top. The ones on the bottom are negative because they're negative exponents. I've got a negative log base 3 of z squared, and I've got a negative log base 3 of y. What else can I simplify on here? Well, remember, logs are saying if the base is 3, 3 to some power is equal to 9. 3 to what power is equal to 9? If you said 2, you've got the right answer. 3 squared is equal to 9, so this piece is going to simplify down to just 2. The other nice and often used properties of logarithms is an exponent inside of a logarithm can come out in front of the logarithm. So we're going to say plus 2 log base 3 of x minus exponent comes out in front, 2 log base 3 of z minus log base 3 of y. This long log is the same as this complicated log. But we're going to find out when you get on to calculus, which, by the way, doing integrals with calculus is one of the main applications of this. When you get to calculus, this top one is going to be really inconvenient to work with, but separating up into these simple terms makes it much easier to work with. So tomorrow at 4:15 Pacific time, 7:15 Eastern time, exclusively on TikTok. So make sure you're following Cheg's TikTok account if you're not already. Exclusively on TikTok, we're going to do a live office hour focusing on just calculus, where we can do integrals, where this log property is going to come in much handy. It's also going to come in handy with some derivative problems. So make sure you log in and join us for that at 4:15 Pacific time, 7:15 Eastern time for an exclusive TikTok Cheg live office hour. This one we're broadcasting, though, on all of Cheg's channels. So make sure you are scanning this QR code so you have the full schedule of what we're going to be taking a look at, what office hours are available to help you be successful in your classes. And make sure you're following Cheg here on TikTok, YouTube, Instagram, Twitch, and more for learning content just like this. I want to give you a huge thank you for joining me today. It has been so fun sharing my love for algebra with you over the past hour. Remember, we will be back here next week, so mark your calendars for 5 o'clock Pacific time, 8 o'clock Eastern time on Wednesday to continue to answer your questions to help you be successful in your classes. And of course, don't forget to check out Cheg.com. We're here to help you 24/7 with all of your toughest subjects, including your algebra and pre-calc. So log in and check out the resources. Remember, we're here this time every week, so I look forward to seeing you next week. Until then,